Hello and welcome to today's lesson, where we shall be looking at the integral of sine raised to the power 3 theta d theta. Now, the method or the approach we are going to present in this lesson works for every odd power of sine theta. That is to say, for if here is 3 or 5, 7, 9, etc. for every odd power of sine theta. This method will always work. However, we should note that the higher the power of sine theta here, the more cumbersome the method becomes. So let us consider this very simple case of sine cubed theta. Now the method is this. Since the function is a function of sine theta, you say let u be equal to what? Cos theta. That's the trick. Since the function is a function of sine theta, you say let u be equal to cos theta. That is to say, if the function was a function of cos theta, like we'll see in the next video, we shall say let u be equal to what? Sine theta. So if u is equal to cos theta, the next thing we'll now do is to differentiate. So du over d theta gives us what? If we differentiate cos theta, we get negative what? Sine theta. We now make the theta here the subject of this equation. So we have, the du is equal to negative sine theta d theta. So that if we make d theta the subject, we have that d theta is equal to minus du over sine what? Theta. So we'll come back to our integral, and in place of d theta, we now write minus du over sine theta, and the job will now be done from there. So this implies that the integral of sine raised to the power 3 theta d theta now becomes the integral of sine cubed theta. Now the theta becomes what? Times minus du over what? Over sine theta. Of course, we can write this as, we'll take the minus out, integral of, now there are 3 of sine here, and there's just 1 here. So one of these will cancel 1 here, and we have sine squared theta du left. Sine squared theta du left. Now that we have this, we can now write it as follows. So we should recall again, recall that sine squared theta plus cos squared theta is equal to what? Equal to 1. So if we now make sine squared theta here the subject here, what do we get? We get that sine squared theta is equal to 1 minus cos squared what? Theta. So if we replace sine squared theta here with 1 minus cos squared theta, we get the following. We get that the integral of sine cubed theta d theta is equal to negative the integral. This now becomes 1 minus cos squared theta du. But initially we had said let u be equal to what? Cos theta. So if u is cos theta, then we'll expect cos squared theta to be u squared. So that this becomes minus the integral into 1 minus cos squared theta becomes u squared du. We can now open up a bracket and integrate term-wise. This becomes minus the integral of 1 du plus the integral of u squared du. So if we integrate these terms, what do we get? The integral of 1 du is u, so that becomes minus u plus the integral of u squared is what? U cubed over 3. Since we are done with integration, plus our constant c of integration. However, in the original integral, we do not have u, but we have theta. So we have said let u be equal to cos theta. So we now replace u with cos theta, and we get the following. We now get that the integral of sine cubed theta d theta is equal to minus, our u is cos theta plus cos cubed theta over 3 plus our constant c of integration. So the method we have used here is by saying let u be equal to what? Cos theta. However, if we also use, we can also use the method of trig identities, and we shall arrive at an integral that has a different form from this one. However, they are equivalent. So if you have not already subscribed to this channel, I suggest you do so that you can always get directly any future updates on the channel. Bye.